So when they write arctan or arc cosine, that arc, all that means is the inverse function of cosine. They also write it like this: cosine to the -1. So make sure you don't mix up the idea of the -1 exponent as a reciprocal. That's not what it means. In this case, they mean inverse function. So the button on your calculator would be arc cosine, the inverse. So if you have like TI-84, that blue writing above the cosine, that's arc. All right, now the inverse functions have a strict domain and range. I don't have any graphs here. Because the originals are cyclical. Let me get the graphs out. You find some good pictures. Right here. So these pictures right here are the definitions and inverses of all the trig functions. So inverse, so here's the original sign, this is arc sine. They restrict the excuse me. They restrict the domain and they cut it off here. Because if they don't, the graph will begin to repeat itself and no longer be 1-to-1. I don't know if you remember in college algebra, we said in order for an inverse function to exist, or the function has to be 1-to-1 in order to find one. So what they did is define the trig function, restrict it, and said, okay, now that it's 1-to-1, because it's no longer repeating itself, I can define the inverse function for each one. So now the domain where I restricted it becomes the range of the inverse, the range of the restriction because it becomes the domain of, okay, and so forth. So they did the same idea to the cosine and tangent. Although the tangent didn't have a problem because it was always 1-to-1, so it was fine. It's just sine and cosine had issues. Okay. So you'll need to have this. Again, I'm going to send it to you, but if not, look up the domain and range for these functions, or write them down from the book or from the notes or from the lecture, whatever. Make sure you have them handy because they're going to be useful. I'm not going to force you to memorize it, just make sure you can bring each up. All right. Okay. I forgot what I was going to do. So the beginning will ask you about the domain and range. What is the domain and range for the inverse trig functions? So that's something you'll have to come up with. Now let's get back to basics here. And here they talk about the restrictions we were just mentioning. Now they want us to use the functions here. So now think back. Right? The unit circle, we said that the sine and cosine were the x and y values. So this So this right here was cosine of 0, right? This over here is sine of 0. So like the output is 0, the output is 1. So over here, right, this one, that output is cosine of pi over 6. But we're all familiar on how to read the circle, correct? Let me pull up the chat just in case. No issues with given an angle, you can find a value, correct?
Yes, sir.
Okay. So if that part makes sense, we can talk about inverse. What inverse function does is you give it a value, right? So for example, cosine inverse, that's an ugly -1. Cosine -1 of 1 means what is the angle that gives you a 1? In other words, if you change this to use the definition, right? Cosine inverse of let's see, how should I phrase it? Of some x value, it gives me an angle theta. So by definition, this means that cosine of theta gives you an x value. That's a definition that we use for inverse. So that means that there's some angle that makes this equal to 1. That angle happens to be here, right? Gives me an x value of 1. So essentially, the original cosine, you give it an angle, it gives you an x value. The inverse takes an angle and gives you the x value because they are opposites, right? The inputs and outputs switch. Do you remember your college algebra, right? General, a function will give you an input. Yeah, you give it an input and it gives you an output. The inverse will take the output and give you the input. It takes you back to where you started. Does that make sense? Okay, I'm gonna assume it does. So arc sine of 0 means sine inverse, right? It's the same thing. Sine inverse of 0 or arc sine of 0 means what is the angle that gives me a y value of 0 on the unit circle? By definition, they're asking sine of what theta gives me 0. What is this theta?
It'd be 0.
Yeah, it's going to be 0, right? So look at the unit circle. right here. The y value at 0 happens at 0. It also happens out here. But what is the domain and range for the inverse trig function? So that's why it becomes important. You're like, all right, well, which one can I use? So look at the locations here. The shitty picture. Can you guys see that or no?
Yes.
Yeah.
Okay. So here's the alternate notation we're talking about. So the range, the angles, the only angles that this can spit out, right? The arc sine have to be between here, negative pi over 2 to pi over 2. I cannot go above pi over 2. So that means that sine inverse can only give me answers from here to here. So I have to go in the negative direction or positive direction, but I cannot pass pi over 2 or negative pi over 2. Even though that's technically 3 pi over 2, I cannot, that would imply I can't go this way to land here. I have to go the other way. So only from pi over 2 to negative pi over 2. So the right hand half of the circle are the only angles I can use. But if I use anything over here, they're going to be negative. The outputs will be negative. So if it happens to be over there, your calculator will give you a negative angle, which can kind of correspond to stuff over here, right? Let me see. Yeah. Yeah, so just keep that in mind. So anyway, let's get back to the homework. There's a lot of theory behind this and definition, so make sure you do watch the lectures and then the theory behind it. It's important. So they want you to find the exact value. So yeah, I don't want you to use your calculator, just think about it. Where is cosine 0? That's the same question, right? At what angle do I get cosine equal to 0? That's what that question meant. Our cosine of 0 is asking what angle gives me an x value of 0. And what theta would it be? What angle?
Pi over 2?
Looks like has to be this one, right? But always make sure, am I good on the domain? Cosine goes from 0 to pi, the top half of the circle. So yeah, 0 to pi would be from here to here, right? This top half. So pi over 2 would be correct. So the answers are easy. The questions are easy, but there's a lot of concepts in the background. Do you see what I'm talking about? Make sure it makes sense.
Yeah, so it just depends on the domain and the range.
Yeah, so make sure you have that at the ready because that'll determine how you find these. You see why this one is impossible? Look at your what's it called, this page I opened up. Not that one. This one.
Is it because it's greater than the domain?
Yeah, the domain has to be between -1 and 1. Our question was 4, right? It's too big. Way too big. We can't use it. All right. Next one. -√3. When does that happen? Well, tangent is defined between, the angle outputs would be -π/2 to π/2. So looking at this, where would that happen? Right, the only way that it would be negative and equal to √3/2 would be, because remember, tangent is y/x, right? So I would have to have a scenario like this. But it's always going to be one of these. But these would cancel, leaving me with √3. So I need this I need the y to be on top. I need this to be on top. And this to be on the bottom for my y and x. So the only one that does that is this. And it needs to be negative, so that's the one. So this location. But I can't go around because it's defined from here to here for tangent, just like sine. So how far is this from here to here? How far is that? About what? 60 degrees, right? Do you agree? Do you see why we chose this particular spot?
Yes, because it was negative. So we're
Yeah.
going, yeah.
Yeah, let's see. Don't forget the question. Right, we needed a negative, we needed a location that would result in a -√3 whenever I divide y/x, because we know that tangent of theta gives me a y/x from the unit circle. So I need a y/x that gives me this, and then find that location, which turns out to be -60 or -π/3. Does that logic make sense?
I'm kind of confused on how we would get the π/3.
Did you agree to the -60?
Yes.
Okay. So it's the same thing, it's just in radian form.
Okay.
That's all. Does that make sense? Because -60 is -π/3.
Okay, yeah, that makes sense.
Okay. If you look at the circle, right, 60 degrees is pi thirds, right here. So going in the negative direction, same deal. This is negative 60, negative pi thirds. All right. So just keep that in mind, and you should be cool with the these values, because there's not much work. You just need to make sure you understand the concept. Now, 13 and 14 are a little more interesting. Ugh. They will remember back in the day, right? These would cancel, leaving you with an x. If you're left with an x, or for example, we have an f equal to x squared, and a g equal to the square root. And if you compose them together and they canceled out like this, then they were considered to be inverses, right? That's what we talked about in college algebra. You combine them together and they cancel out. Square root and x squared are opposites, they are inverses, so composed together they cancel. These are inverses of each other. So they should cancel, leaving you with just the x value. Does that make sense?
Yes.
But the only issue is whatever is inside here that I circled. It will only cancel if the domain's okay. Like we can't just assume, oh yeah, 37, who cares? Like you need to make sure and think about it and see, okay, well, what is my domain for the inverse? Is 32 or whatever it was in between here. Like, yeah, it looks like we're good. So now let's not worry about it. Tangent doesn't really have any issues. Tangent inverse. So who cares? But look at this one. This one is already telling us it's impossible. So we need to figure out, okay, well, the one in here, does it violate the domain and range stuff? Go back to our cosine. Our cosine needs to be between -1 and 1. Negative root 2 is what, 1.2 something, whatever, I don't know. It's below -1 for sure. So since I can't actually plug it in, then it can't cancel, right? I can't cancel something that was never allowed in the first place to be in here. Does that make sense? Just can't. Any questions on 13 or 14? Now, 7 pi thirds. See, these should cancel, and it feels like we should just get this 7 pi thirds, but I don't. I get pi thirds. So we need the coterminal angle that is less than 2 pi. So 7 pi thirds, where would that be? Right, 1 pi thirds, 2 pi thirds. 4 pi thirds. 5 pi thirds. So 16. So another one. 7 pi would be all the way back here. So this is the same as 7 pi thirds. Just goes, there's an extra 2 pi on top of it. But 2 pi plus pi thirds is 7 pi thirds. So in the homework, it's the angle's too big. So just adjust it. Remember how we did we had too many revolutions, we'd say, all right, well, this is too big. So subtract 2 pi, right? Do your fraction nonsense. Get us to pi thirds. So now I have a better coterminal angle. So these will cancel, leaving me with pi thirds. So I'm going to use this one, not this one. Okay. Does that make sense? Like you have to use the 1 less than 3/6 or 2 pi. Any questions on 15? 16 is the same thing. All right. So let me know if it's not making any sense. Delete these word problems for you just because I don't want you to suffer too much. Let's see here. Not worry about it. Okay. So that's pretty much 6.6. Let me see what the syllabus says. Where are we? All right, so at this point, we should probably review a little more and just chill. I think we're good.
As long as we go like over the homework that we already been doing, like we should be good, right?
Yeah, I mean, make sure you do the review a couple of times.
Okay. Okay, for sure.
Yeah, do the review. Just remember not to do anything about partial fractions.
Okay.
Skip those. And yeah, homework is good. Just make sure you write everything out because I'm expecting you to have your work written out. Yeah, so we'll use the rest. You guys have any questions at this point? I don't want to go too far ahead. We're technically a little bit ahead. you have any questions about the exam?
Yeah, when are we supposed to do the exam?
Anytime before, let's see. Don't recall. Before October 3rd, so, I mean, I'd rather you do it this weekend if possible, but. If you wanna wait till the last minute, it's kind of your call, right? But I recommend trying to get it done next week or this weekend, if you can.
All right, thanks.
Yeah, cause today's the what, 20? I think it's today. 27th. So yeah, you actually, it would be due next Tuesday, so I think the sooner the better. Just make sure you're ready, then your homework's knocked out. The homework should be done before this weekend and then just spend the weekend reviewing, you should be great. That's what I recommend. Also, make sure ISLO is already done. If at some point I'm gonna check, and if you haven't done it, I'm gonna lock you out from everything. Till it's done. Guys have any questions about your review stuff or homework? Things, other things in general?
I did have a question. Are we able to use any notes for the exam?
You can use a unit circle. A page of formulas, front and back. You can also add definitions, but no examples. And you'll upload that with your exam work.
Okay.
Okay, you said we can use formulas and definitions?
Yeah, the definitions, formulas, and a unit circle.
Unit circle, perfect.
The unit circle does not count towards your page of formulas. It's its own separate thing. Let me take roll to forget sometimes. Is Aaliyah here?
Yes.
Jamila?
I'm here.
Okay. Gabriel Eastridge? Victoria Espinosa?
Here.
Did you say Vanessa? I'm sorry, I can hardly hear you.
No, I said Victoria.
Oh, sorry.
Haley?
Here.
Brianna? Okay. Blanca?
Here.
Great. Gavin?
Here.
Priscilla?
Here.
Matthew?
Here.
Serena?
Here.
Josette?
Here.
Natasha?
Here.
Monica?
I'm here.
Vanessa?
I'm here.
Zachary?
Here.
Jeremiah?
Here.
Okay. And Brianna, yeah, let me change it to present. Okay. All right, guys, if you have no questions, feel free to head out. If not, I'll stick around and help you out.
Did you schedule 9.4 for homework? I saw it was going to be on the unit test. But it's not like it still has like a December 15th due date. So was that something we were supposed to be doing?
9.4 will not be done in this semester. I'll be sure to remove it if it appears. It's on the exam, or what'd you say?
It says unit 1 test over sections 9.4 and 6.1 through 6.5.
In Canvas, right?
I'm looking at your syllabus.
Yeah, we just changed that. We used to have 9.4 on the test, so it's gone now. That's
Okay,
the
thanks.
partial fraction stuff on the review.
Yes, and then I noticed it when you pulled it up on your screen as well. So okay.
Yeah, it needs to be removed. To answer your question, no 9.4. Do not do anything that has to do with partial fractions, okay?
Okay.
But,
So it's just 6.1 through 6.5. 6.6 won't even be on there.
right.
Okay.
So I need to double check and delete them, but if you do see a question about partial, just skip it, okay?
Thank you.
Yeah, no worries. Delete that before I forget. Let's see. I think I already did.
When will the class for today be put on remind?
I'll try to put it let me see, probably tomorrow morning. I try to do it in the morning, the next day. Most of the time it's up right away. Sometimes I get behind, but should be tomorrow.
Okay, thank you.
Bye. Thank you.
Oh, good night.
See you Monday.
See you Monday.
Bye. Thank you.
See you later.